Why do op-amps ring? Ringing is a term used for when an output signal oscillates. For instance, when you put in a step response and we have to an underdamped system, right? To ring, the system must be underdamped, which means it has to be at least a second order system with two complex poles. Op-amp circuits can ring when there are more than just one compensation pole, modeled as AV over S or AV S plus omega naught. But so these two on their own can't oscillate because they're just first order. So if your op amp is oscillating, where are these extra poles coming from? Well, poles and zeros come from energy storage elements, and anytime you have two different kinds of charge separated by a dielectric, there's a capacitor. Whether you want it there or not, it's there. Op amps are made out of transistors which have many capacitances associated with them. You learn all about it in 124 and 128. PCB boards have capacitances between wires and ground planes. Resistors and inductances have capacitance as well. Anytime you have charge throwing through any shape, there's an inductance associated with it. Truth is, even a simple voltage divider has capacitances and inductances associated with the circuit that we tend to ignore at low frequencies. Now here's the trick. When do you ignore it? When your experience tells you not to. How do you gain that experience? Getting bitten. So let's just do a simple op-amp buffer, right? So let's just get the system model first. This is the setup to level 1, and we put in a voltage, and we're just measuring the open loop gain. We can see that at close to DC, it's 120 dB, and that we've got a cutoff frequency of about 10 hertz. And I'm pulling that off where the phase is minus 45. So the system model is this. All right. We add a capacitor to that, and we actually get the same thing. Why? Well, that is a ideal voltage source inside of here, and which can drive anything. Now, real op amps are not ideal voltage sources. They have a series resistance on the output, which I've modeled here with this 10 ohm resistor. This is still the level 1 op amp model. Now, this series resistance is inside the op amp, what I'm circling around. What happens now? Well, you can see that created another pole because really this is acting like a low pass filter, right? It's operating at a higher frequency, but it still is. Can this ring? Well, let's look at the phase. It goes from about 0 to 180. And because I can see these two distinct humps in the phase and two distinct slopes in the magnitude, it can't be, it's overdamped because you can see the two real roots there. So that's overdamped, which isn't going to ring. Let's wire that into a buffer and see what happens. All of a sudden, we've got ringing, because by wiring this in, okay, this is creating a voltage divider with frequency, which is being fed back. Before, we would have said, oh, what's like in a normal buffer without this capacitor and without this, GS, or how much is fed back, would be 1. But now, actually, what's being fed back is this voltage division, which is, in fact, you're feeding back a low-pass filter. So you're changing it. So now the phase goes from 0 to 180 with almost zero transition, and you see this peak, which means it's underdamped, which means it's going to oscillate. So if I put in a step function, you can see this is, I set the example to be really oscillatory, so it'd be quite obvious. And we zoomed in here, right? Now, let's try a different op amp model. right? So we were able to get a first order model, right, to become second order by adding a series resistance and a capacitor, which when fed back could cause it to oscillate. Now that we've made the op amp now level 2, and we still have our first pole here, but now there's a second pole out at 3.5 gigahertz. To look at the circuit, you wouldn't notice any difference. You'd have to edit it to see that the fact that it's we set it to level 2. So we wire it back in as a buffer, no output capacitance, and we see, yeah, this sharp roll off. We see one slope, two slopes, so it's second order. Might be easier to see that the phase goes from 0 to 180, and I can see these two distinct humps in the phase, which means the poles are real because they're distinct. So this isn't ringing all on its own. All right, we add a capacitor, and that capacitance is affecting this. All right, where before it didn't. Well, because I believe that the second order op amp model has an output resistance on the inside that you can't see. All right, and then yeah, when we wire it back into a buffer and just put the capacitor on it with a level 2 model, we're going to get this underdamped response, so we'll get ringing. So I said, why did it ring without that output resistor? Because I believe it's inside. And if you look at this file here, it's how to use the universal op amp model, and there's level 1, 2, 3A, and 3B. And right here in the directions, it's a single pole op amp with one internal node. Not quite sure about that because it was second order before, but this one internal node is making me really think that's where that output resistance is residing. All right. Now I wanted to go a little bit farther and say, well, what is the system of that op amp? System ID comes later, but basically that was the DC gain. Here are the two roots. I have to multiply by 2 times pi twice because at 0 frequency I would be left with these terms. Actually, okay. And the gain is 1. So if I use my feedback methodology, you'll find that it, without the load capacitor, it should still be overdamped. And the reason why it only rings when you add this capacitor, and that internal node then separates it out. Now the thing is if we look at some real op amps, here this is the Analog Devices 795, and you can see that there's a lot going on here where the phase goes down to minus 800, right? So basically that's quite a lot. But why do op amps ring? Basically you've got at least a second order system, and when you've got the feedback, or maybe not even you got a second order system that when you hook it up gives you at least 2 complex poles. You can even get this with first order models when you add an output capacitance, not just by itself, but connected through a series resistor. The level 2 model, you don't need that resistor there. And when you wire it up, you